Hi, everyone, and welcome to the workshop on validating infrastructure and enforcing OPA policies using Terraform and Terraform Cloud features. I'm Rita Sokolova, a product education engineer at HashiCorp. Presenting with me today is Cole Morrison, who is a developer advocate at HashiCorp as well. Throughout the presentation, we will be fielding your questions in the chat and through the Q&A cards that are in the HashiConf platform. And helping us field those questions are some teaching assistants. We have Jerome Papazian and Cedric Weiss, who are solutions engineers at HashiCorp, Adrian Lopez, who is a site reliability engineer working on Terraform Cloud, and Garrett Brown, who is a solutions architect at Styra. And our chat moderator is Jonah Applebaum, product manager. Throughout the presentation, we'll be adhering to the Code of Conduct, which you can review on the HashiConf website. So why use automated validation and enforcement? Smaller organizations who are just starting out with their infrastructure provisioning workflow through Terraform likely have informal agreements for their infrastructure configuration standards and practices. So what this means is that you likely have very thorough review of any of the resources that you're about to deploy, and a lot of that responsibility is on your team members themselves to remember those standards and then also verify them anytime you're introducing any changes into your infrastructure. As your organization matures, that sort of ad hoc compliance can falter and it becomes harder to enforce. You likely have more resources, your standards are growing more complex, so it's a lot of responsibility to offload onto your team members. What you can use instead are automated validation mechanisms. So what that means is that you're likely codifying your rules and standards and defining a clear source of truth, perhaps in a VCS repository. Since they're codified, that means that you can trust that there's consistent application of those standards because it's automated. So that reduces the risk of operator error. It means that you're not relying on your teammates and organization members to enforce those standards. You're just trusting the systems that you've put in place to validate your infrastructure. So one type of validation mechanism is configuration level validation within Terraform. So the first that you may be familiar with is variable validation, which allows you to define conditions on your input variables. This can use pre-built or built-in Terraform functions. You can also define a regex or a list of acceptable values and check the variable input value against those conditions. Starting with Terraform 1.2, we've also introduced pre- and post-conditions, which are resource-level validation. So you define a pre- and post-condition within the resource itself, and then based on that passing or failure, Terraform will complete the run. So preconditions these occur at different times in the infrastructure provisioning workflow. With preconditions, you write your configuration and include the precondition within the resources that you've written. Terraform will then validate that precondition prior to the resource block that encloses it, and if the condition is satisfied, it'll go ahead and create the resource. So this is useful for any values that you may know ahead of time. It's similar to variable validation. Perhaps you want to check on an attribute that you have configured or something that relies on a variable value. Post conditions happen at a different stage. So you write your configuration, including the post condition, create the resource, and then Terraform will perform the validation. So this is useful for generated values that are known after provisioning time. Perhaps you want to verify that the instance that you're deploying was assigned a DNS record, or that it was deployed within a specific subnet. So you can use post conditions to validate on those unknown values that are generated once the infrastructure resource is created. Another type of validation mechanism is policy as code. So HashiCorp offers Sentinel, which is available for enterprise tier users, which allows you to define policy checks within code. We also have Open Policy Agent, or OPA, which you may be familiar with, which is not specific to the HashiCorp products, but that's the one that I'll be demoing today. So specifically, I'll be using OPA and the Styra integration through Terraform Cloud Run Tasks. OPA, if you're not familiar, is a policy as code engine. So it decouples your policy definitions from your code itself and enforces those policies through the open policy agent, and the policies are written in the Rego configuration language. Styra offers the declarative authorization service, which is a single control plane that allows you to both manage your policies and the agent deployments that will enforce the policies within your systems. So as I mentioned, I'll be using a run task in order to integrate OPA into my infrastructure provisioning workflow. Run tasks are a Terraform Cloud feature, and they're an organization level resource that allow you to extend your infrastructure provisioning workflow with third-party tools. So you can integrate code scanning, cost estimation, and compliance, such as policy checks. So the way the run tasks work is you create the organizational level resource of the run task and then associate it with your chosen workspace. Once you do, on any of your future Terraform plans, Terraform will send the plan details, including the proposed resource changes, to the configured tool, which in this case is Styra. You can set two different enforcement levels on a run task. So there is an advisory level and a mandatory level. With an advisory level, if the run task returns a failing code, you can still create your resources. You'll just be notified that there's been a violation of the policy or check that you configured. If you set the mandatory enforcement level, any failures will prevent the creation of infrastructure. So in terms of how these validation mechanisms work together, I'm going to work from the smallest unit in this diagram out. So pre and post conditions are specific to the module that you define them in, and they will only validate the configuration within the resources of that module itself. So you have no guarantees on the other resources within that workspace that are not using those module definitions. At the workspace level, you have the run task. So you associate the run task with your Terraform Cloud workspace, and on any runs, it'll perform the validations configured by that run task. At a broader level of your Terraform Cloud organization, you can use Sentinel. So Sentinel can apply across all of the workspaces, and that's one way for you to get policy checks in every single workspace rather than having to associate one workspace with a run task at a time. So in this workshop, I'll be going through a HashiCorp Learn tutorial to show you how you can configure validation mechanisms to establish some of these compliance guardrails within your own environments. So first, I'm going to show you how to use a precondition within a module, and specifically, I'm going to use one to prevent over-provisioning a Bastion host with too many CPUs. And then I'm going to use the Styra run task to enforce two different types of OPA policies. So first, I'm going to use an Styra public library policy in order to prevent the creation of overly permissive AWS security groups. Then I'm going to define a custom policy within Styra that will prevent Friday Terraform Cloud deployments. To do all of this, I'll first define a precondition within my configuration. I'll then show you how to configure the Styra and Terraform Cloud Run task. I'll use that Styra library policy for my AWS resources, and then I'll define a custom policy within Styra as well. It's worth noting that throughout the workshop, I'll actually be doing the function of three different personas that may exist within your organization. So at the first level are the operators, and these are the engineers that are developing your Terraform configuration and deploying Terraform resources. They're likely the consumers of any modules that your organization has developed. There's also the security persona, and those are the team members who are responsible for defining your OPA policies and determining which guidelines are appropriate for your organization. And then finally, there's the platform engineer persona, and those are the team members who are managing your Terraform Cloud and Styra integration, configuring your run tasks, and determining which workspaces you can apply them to. So before we jump into the demo, Cole, do we have any questions yet?
I do not currently see any. It's going very smoothly right now. So.
Great, let's jump right in then. So as I mentioned, I'll be following along with a tutorial that's available on HashiCorp Learn for the workshop. And I'll be relying on a few different services in order to accomplish the tasks that I had outlined. I have Terraform installed locally. I'm using AWS as my cloud provider to create my resources. I have a Terraform Cloud account with the team and governance tier enabled so that I can use run tasks. And then I'm also using a free Styra account to manage and enforce my OPA policies. For the tutorial, I'm working with example configuration, and it relies on a local module that I've named network. So let me review the configuration that I've defined in here. First, I'm using the publicly available VPC module in order to create some networking resources. So this spins up a VPC, public and private subnets, a NAT gateway, and the route tables for those subnets. Then on top of that, I'm also creating a Bastion host and a security group for it. So if you're not familiar, a Bastion host is intended to be a single point of entry for SSH traffic into a network. So if I deploy this within the private public subnets of my VPC, it means that any services within the private subnets of that same network should receive SSH traffic through this Bastion host. It means that I don't have to expose those services that are within private subnets to public internet ingress. So I have my EC2 instance definition for the Bastion host. It's configured using an input variable that sets the instance type. I'm also using a data source for the AMI, and then assigning it a subnet that's created by that public module and a security group. A security group, just created up above, restricts any ingress traffic for port 22 for SSH to this example CIDR block, which could represent your company's internal VPN or your office network. In terms of the input variables for the configuration, as I mentioned, I have the Bastion instance type, and then I also have input variables for the VPC, private, and public subnet CIDRs, which have default values configured. Now, by configuring my module to include both those networking resources and the Bastion, I'm setting the standard that anytime someone's using this to create a network, they should be using that Bastion host in order to access any of the instances that they deploy within my network. So I'm sort of setting an organizational standard around how resources should be connected to within that network. Now, even though I'm allowing for the instance type to be configured using an input variable, I may not want to allow users to set just any instance type. Since this is a Bastion host and it's only going to be receiving SSH traffic, it wouldn't really make sense for this to be over-provisioned with too many CPUs. One way that I can prevent that is by configuring a precondition on the resource. So to do that, I'll first define a data source to get information about the instance type. What this does is it takes the input variable that's passed into the module for the instance type for the Bastion, and it queries AWS to get the details for that instance type. So this will return the CPUs or cores that are configured for that instance, default memory, whether EBS encryption is enabled, all those details for the instance. Then down in the resource definition itself, and I'm copy pasting all of this configuration from the tutorial on HashiCorp Learn, I can set the precondition. So let me zoom out so you can see the whole thing. So preconditions are defined within the lifecycle block of the resource. The way that this works is that since it's a precondition, Terraform will first evaluate the condition that I define here, and then determine whether to create the Bastion host that encapsulates this condition. So the condition checks whether the default cores for the instance type is no more than 2. And if the condition fails, it'll display an error message within the Terraform run output to the user, telling them how to correct the issue. So I've set the instance precondition, and now I can jump into the configuration. So for the sake of ease, I have my module packaged within this example repository, so I can access it locally. But when you're working in production, you probably have your modules stored in the Terraform registry or somewhere else that your team can access them. And what this means is that you have that sort of decoupling between the modules, the defined pre and post conditions in them, and the downstream consumers who will be using those. So they may not have access to the exact preconditions as they're defined within your configuration. So within the configuration itself that uses that module, I just have my provider definition. I reference that local module from within my repository. and I set the Bastion instance type using an input variable. Now, for the sake of demonstration, I'm going to use a T2 2x large to start, which I know has 8 cores, but let's see what happens when I try to provision infrastructure with a failed precondition. So I'll jump into my terminal. And one thing I didn't review is actually my backend configuration. So I'm actually using Terraform Cloud for these runs, and Terraform will create the Learn Terraform Validation and Enforcement workspace for me once I initialize my configuration here. So to start, I'll set my Terraform Cloud organization name. And then I'll initialize my configuration to create that workspace. Then I'll attempt to create my resources, and I do expect this to fail. Give it a second. And while it's, oh, sure, go ahead, Cole. I do have a second if we have a question coming in.
We do not. I do have some questions in general that perhaps we can talk about once you get some time and opportunity, but it looks like your thing may have just finished. So
yeah, my precondition failed timely, but I'm happy to return to those questions in just a bit. Yeah. So as configured, the precondition did not allow me to over-provision my Bastion host, and it actually tells me that the CPU, the default cores on this instance type, is 8. And it's useful to let users know exactly how to correct the issue within that error message. So I know to go and update my input variable value now. So I'll go back to my variables file here. And I know that a T2 small should satisfy these conditions. And then I'll attempt to create my configuration again. And we expect it to pass this time. So while it's streaming the output in the terminal, I'm using CLI-driven runs. So these are also going to be tracked within my Terraform Cloud workspace. So if I jump to that within Terraform Cloud, I see that I have a run in progress and it's planning now. And it'll stream the plan output here as well. So jump back to my terminal to finish this up. And this time it was able to generate the plan and it'll allow me to apply it. It'll just take a second. Cole, if you got any questions, I think I have a moment to cover them now.
Yeah, apologies. This kind of goes back to before we hopped into the demo. But I figured it could be good for some clarification, and that was around the Styra systems and Terraform workspaces. You mentioned and you showed the overview, but I was wondering if you could elaborate. Can you add a single Styra system to multiple Terraform workspaces?
Yeah, so we'll be covering this once we jump into the Styra configuration, and I'll show you exactly how to do that. But you can have multiple collections of policies that apply to as many workspaces as you wish. So you can have one set of Terraform Cloud Styra policies that will apply to just one workspace, or you can designate perhaps a development set of policies and a production set of policies and apply them to the relevant workspaces there.
Okay, gotcha. So we will be able to see the usage of different policies with different workspaces. Okay.
Yeah, awesome. That's right. Yeah, then that'll be configured in the Styra UI just a little bit later in the workshop.
Perfect. Well, why don't you let me know when you have time for another question, and we can go into some other stuff.
Sounds great. So while my resources are getting created, it's worth mentioning that I actually could have accomplished something similar using variable validation, which is that other configuration level validation mechanism that I had mentioned earlier. The way that that would look would be something like this. So as an example, let me just grab my example variable validation, paste it in, have him format it for me. So if I was using variable validation instead of a pre and a post condition, it would look something like this. I would create my variable and include the condition within the variable definition itself. And I would list out the list of acceptable instance types that I know have no more than 2 CPUs for the instance. This doesn't make my configuration very flexible. What this would mean is that I'd have to go into AWS, research all the research all of the different instance types, check their configuration, and then list them all out here. And this isn't even a complete list that would satisfy the condition. It also means that if AWS introduced a new instance type, my configuration would become outdated. So by using the precondition instead, I can query AWS for the most up-to-date information about that specific instance type that I've passed into my configuration. And it makes my configuration more dynamic. I don't have to have this kind of useless list of instance types within my variable definition. So a little bit of better practice using the precondition rather than the variable validation in this case. I'll delete it so I don't have it there. And let me check on my run. Still going. So Cole, I think I have some time for another question if you've got one.
Yeah, sure. So this will come back, and I think you're going to show it a little bit. But we keep talking about postconditions, preconditions, Styra, and the like, and obviously we touched on Sentinel. I was wondering if perhaps you could elaborate a bit more on the difference between Sentinel and OPA/Styra. Obviously, there is the how it works, but perhaps from like one of those personas, like how you would think about it.
Yeah, so it's a matter, the primary difference is the scope of the application of the policies that you define. Both are using policy as code. They are written in different languages. But with Sentinel, you can apply it to the entirety of the workspaces within your organization. Meaning, if you do enable that feature as the platform team within your organization, you can trust that there aren't any workspaces that are slipping by. With a run task integration, that depends on the workspaces that it's associated with. So it's a little bit more granular in terms of the configuration that you set. Both are running on the plan details, but with Sentinel, you can also operate on the TF run details and the state. There are just different types of imports that you can use for your Sentinel policy definitions, whereas OPA is just using the JSON format of your Terraform plan, which does include those resources, but it's all in one file.
Oh, okay, I gotcha. So the level of control is one part, right? So Sentinel, more level control you can get down. It's got its own language, so you can do quite a bit. Obviously, OPA has it as well. Right. And then also whether or not you're applying it to all workspaces or just one, right?
Right, that's right. Cool. Neat, thanks. And I think we'll have more time for questions in just a bit. But in the meanwhile, it looks like my resources were created. And if I go to Terraform Cloud and check on my runs, I do see that it was applied. And my resources are now tracked in my Terraform Cloud workspace. So this worked. I saw that the precondition prevented the creation of that overly resourced bastion host. But as I mentioned earlier, the guarantees within preconditions are kind of limited. So the only sort of peace of mind I have that the preconditions are being adhered to is to the extent that module authors within my organization are defining them within the configuration, and that engineers are actually using those modules to provision their resources as well. So if module maintainers are not including preconditions, there are no checks. And if my developers are not using those modules to create resources, obviously no one's using modules that do have preconditions in them to validate it. So you can use policy as code for broader level enforcement of any of your organizational standards. And as I mentioned, I'll be using OPA and the Styra run task for this workshop for those checks. So to start, I'm going to jump into the Styra console, and I'm using a free Styra account for this. So you'll be able to create the systems that you need for the associated workshop tutorial with a free account. When you create it, Styra creates the workspace for you. Now, this is different from a Terraform Cloud workspace. This is the container for all of the different types of systems and their policies that you will manage within Styra. A system is a collection of policies relating to resources of a certain class. So you can have a system for Terraform, which will enforce policies on resources that you create using Terraform. You can also have a Kubernetes system for any Kubernetes resources within a cluster. You can have a Kong system, which will validate any requests against the API gateway. So there are collections of policies for specific resource types, essentially. And for the workshop, I'll be using, as expected, the Terraform system type. So create the Terraform system. I'll name it TFC and click Create. So for the tutorial and for this workshop, I'm using the Styra DAS web UI in order to manage my policies. But you can also configure this to source your policies from a VCS repository for some of those policy as code benefits. The UI is useful if you're newer to OPA because there's a visual policy builder. There are some mechanisms for validating your policies against example inputs here as well. And for the sake of the workshop, there's a graphical interface that I can use to walk you through some of my policies. When you configure a new system, it pre-generates some example directories within that system. You're not required to use these. These are just intended to help you get started and organize your policies. But Styra will evaluate all of these together. So under the policy directory, I have an AWS directory, which is the one that I'll be using, one for Azure, one for GCP. So now I've created the system. I haven't defined any policy yet, but I have to finish configuring my Terraform Cloud integration. So under the workspace settings, if I go to Terraform integration, I can enter my organization name, which is HashiCorp training, and then I'll have to input an API token. That is not my API token. If you jump to Terraform Cloud, you can find your API token under your organization settings and API tokens. Now I had generated mine earlier so that I don't have to share it with the world, but you would find it here if you needed a new one. I'll grab mine and paste it into that integration configuration and click save. Once I do this, Styra displays a link to your Terraform Cloud organization and the run task that it created within your organization. So let's verify that that was actually created. Run tasks are also an organization level resource. So under your organization settings, jump to run tasks, and I see my Styra DAS policy check. If I go to the details, Styra actually inputs the endpoint URL for the integration and the HMAC key that it'll use to authorize your requests into the run task, so you don't have to configure that yourself. So the next step is actually to associate this run task with my workspace. So I'll jump to my validation workspace. And under settings and run tasks, I'll select my new run task. And it's letting me choose that enforcement level. So as I mentioned earlier, the advisory enforcement level will allow for failures to still create infrastructure resources. It'll just notify the user that there's been a violation. And the mandatory enforcement level will prevent the creation of any resources in the event of a failed run task. So that's the one that I'm going to choose. And then there's one more step. So Cole, as you asked earlier, is there a way to determine which of the systems are mapped to which of my Terraform Cloud workspaces? There is. So if you go back to the Styra workspace or the Styra UI, under the Terraform Cloud integration details, there's this DAS Terraform system mappings section. So if I add the system mapping, I can select a system. Right now, I only have one. And then I have to map it to my Terraform Cloud workspace IDs. In the UI, you can find the ID under your workspace name. So I'll copy that ID, paste it in here, and hope it lets me click save. There, it does. So as we had mentioned earlier, this means that I can have multiple types of the same system. So I could have multiple Terraform systems with different types of policies. Perhaps they're environment specific or specific to a type of resource. And this is how I can determine which collection of policies maps to which of my Terraform Cloud workspaces. So at this step, we've finished the one-time configuration steps for enabling that Terraform Cloud Run task within my organization. And we can jump into creating a policy. So since the resources that I'm working with are configuring network access to that VPC, and I'm trying to use the Bastion host to limit ingress traffic into my private subnets, it might make sense to create a policy that limits the creation of overly permissive security groups. This means that any resources created within that module, even if they, or not that module, that workspace, won't have overly permissive security group rules. And that gives me some guarantees that are not tied to the configuration itself, but I can trust that the run task will validate it. So if I jump into my AWS file here, I can actually reference some of the public library policies that Styra maintains rather than having to define my own. The way to do that is to click Add Rule up here, and I can start to search on all of the publicly available policies. I know that there's a security group one, so I'm going to find and select that and restrict ingress from public IPs. So Styra will add in that policy rule into the file, and it references the public policy name. It also includes some details on the left here around what are the conditions that will satisfy this policy and what resource it checks against. Now within Styra, there are also different enforcement levels. The ignore level means that if you have the rule definition within your system, you can test it within this environment, but it's not going to be applied to any runs. The monitor enforcement level will, similarly to that Terraform Cloud enforcement level, allow for failures. It'll just notify you, but it won't block any of the checks. And then the enforcement level will prevent the creation of any resources that violate the policy that I've defined. So I'm going to select the enforce mode and click publish for the rule to take effect. So at this point, I know that I can't create any violating security groups with this policy applied within the workspace that I've associated the run task with. Let's imagine now that there's a production incident, and for whatever reason, my engineers can't actually get onto the Bastion host from that restricted CIDR block that I've set on the security group. What they may do within the configuration is try to create a more permissive security group to get onto the network to troubleshoot the issue. So if I jump into my configuration, they might create something like this. Though in this case, I'm the one creating it since I'm straddling all those different personas. And I'll jump up to the top. So first I'm grabbing the details of my deployed Bastion instance. This will give me access to the network interface, the IP of the instance, any of the other instance details within my configuration. Then I'm going to define my not great security group. So this allows ingress to port 22 on the instance that it's associated with from all IPs. And then I'm going to try to associate my security group with the Bastion through its network interface ID that I grabbed from that data source. So I'm hoping that the policy will catch this violation and prevent the creation of this resource. I'll jump into my terminal and try to create it. And follow along on the run in Terraform Cloud. Now this will take a minute, so if we have any questions, we could address them now.
Yeah, I actually have a question from the audience, which is, what advantages do run tasks and preconditions give us compared to Sentinel policies? I'm struggling to see a difference between the two. That's one of our questions.
Yeah, so preconditions are at the level of your configuration itself. So it'll catch it before having to apply those policy checks to your run. So if you know ahead of time that there are some instance types, as we had in this configuration, that you don't want to approve of, you don't even have to get to that policy check phase. Those preconditions and postconditions will catch it earlier on within the process before even trying to create the resource. Run tasks allow you to integrate a variety of external tools. So rather than being limited to just the policy checks within Sentinel, you can also add run tasks for code scanning, any other security vulnerability tools that you want to integrate in. You could also write your own run task integrations. So this will be a check within your workflow rather than just being a policy definition. So it just offers a wider library of tools that you can use within your workflow. Cool. And as expected, the task failed, and I see that in my Terraform Cloud output. I also will see it in my terminal output. But within the Terraform Cloud run details, I can actually click details to get more information about the failure. And this will take me to the specific Styra decision for the run. Let's see that it's already here. Great. So I see that the run was denied, and it also displays the reason for it, which is that the security group has unapproved access from the public CIDR. So even though my engineer tried to create that overly permissive security group, that policy caught it and prevented its creation within that workspace. So I've shown you an example of how you can use one of those public library policies in order to prevent the creation of violating infrastructure resources. You can also use OPA and policy as code to enforce organizational practices. So one example that I'll be showing you now is preventing Friday deployments within your organization. Perhaps you want to give your engineers peace of mind before the weekend that anyone on call won't have to deal with a production incident late on a Friday afternoon. You can add a policy within your system to prevent that creation. So as I mentioned earlier, these directories are not required. They just help you organize your policies within Styra. So I'm going to create a new one for my Terraform Cloud policy. Name it TFC runs and call it rules.rego. And this will create that new directory for me. And I'll jump into that file and paste in the rule from the tutorial, which looks like this. So this rule, which also has that enforcement level, will check whether today is a Friday, and if it is, it'll deny the deployment. Now, today I believe is a Tuesday, so for the sake of demonstration, I'll update the rule to block Tuesday deployments. And click publish for the rule to take effect. So because I'm within this directory in this editor, it shows that there's only one rule in effect within that scope. But if I jump up to the system itself, I see that there are two rules in effect right now. So my AWS policy is still in effect, preventing the creation of that security group. And I also have a no Tuesday deploy policy right now. So let me jump back into my configuration to see what happens when there are two policy violations. I'll try to create my resource again, and it should still fail because it is both a Tuesday and I did not correct that security group. I'll track the run in Terraform Cloud. And wait to see the results of the run task. Cole, do we have any other questions in the meanwhile?
Yeah, we have a couple here. One goes back to when you brought up the different levels of policy enforcement in Styra versus our run task enforcement. Because on our side in TFC, we have mandatory and advisory, but like you said in Styra, they have their own different levels. How do those interact with each other?
Right. So one of those determines the response code that Styra will send back to the run task, and one of them determines how Terraform Cloud handles it. So based on the ignore, monitor, or enforcement mode within Styra itself, that'll determine whether it marks the violation as an error that blocks the deployment and a true failure, or something that is just an alert within the check. Then within Terraform Cloud, that enforcement level determines what you do with that status code. So if you do have the enforce mode set within Styra itself, but you only have the advisory level set within the Terraform Cloud Run Task, it'll notify you of the failure, but still allow for resource creation. So if you truly want to make sure that any policy violations prevent the creation of resources, you also need to set that mandatory enforcement mode within the run task so that it stops the run in the event of any policy failures.
Nice. No, that was great. That was great. So Styra returns the actual code of what happens, and then TFC says what to do with it.
That's right. Yep.
Cool.
So as expected, the policy check failed once again. And if I jump to the details within Styra, I should see a new decision, and I do. So now I have failure on two policies. I know that I can't deploy on Tuesdays, and I never fixed my security group. So this prevents the creation of your violating infrastructure resources. It also stops engineers from introducing any instability into your environment on a Tuesday in this case, but you may actually not want to completely block infrastructure deployments on a day of the week. Perhaps there's an incident and you actually need a workaround for the engineer that's on call. I can modify my policy to account for that. So within the Styra UI, you can actually expand the decision to see the details for that run. And this is a pretty massive file. This contains all of the details of my Terraform plan, along with some details about the Terraform Cloud Run. So in here, I have all of the proposed resource changes, along with a field called Styra TFC webhook, which has contents that look like this. It includes details about whether it's a speculative run, the name of the organization that I'm running it against, what time it was created at, who created at, other details. So I can actually integrate this into my policy decision. And I may want to do that in order to allow some set of engineers to override that no Tuesday deploy policy. So to do that, I'll jump back into my Terraform Cloud Runs rule and update my policy definition. So first, I'll define a list of acceptable users up at the top, and I'll reference my own username here to unblock myself. And then I'll also update the rule definition. So first, I'm going to reference that field from the plan details that tells me which user created the run. And I'll also update the condition to check that the user that created it is not a member of this allowed users list. And update the error message so it's a little more helpful, except it's Tuesdays. So the way that this will work now is it'll check the user that created the run from that Styra TFC webhook field in my plan details. And if it's Tuesday and I'm not in the allowed users list, the policy will fail. So I'll publish it for it to take effect. And let me also update my security groups so that I can actually create the resource. So I'll jump into my configuration and update the rule to actually use my own private subnet CIDR. So let me grab the value. There we go, that should be acceptable. And try to trigger another run. So in this case, I've modified my policy to unblock engineers. For the most part, this would still prevent anyone who isn't me from deploying resources on a Tuesday at this time. But this shows you how you can both use policies to establish guardrails, but also enable your infrastructure operations as necessary. I'll jump back into Terraform Cloud to track this run as well. And while we wait, are there any more questions from the audience?
Yeah, so there's another one around policies. It's kind of a mix between both, since it's kind of be a circular workflow to an extent. But how do you manage and organize all of these policies? Like, I know that there's a default way that the system gives you in Styra, but do you have a recommended approach?
Yeah, so it's a matter of your organizational preferences. Those directories are there to help you reason about how your policies are organized. And it may make sense to group them by collections of resources, cloud provider, but it's largely at your discretion how you structure those. There's some guidance, I believe, on the Styra website around any of the requirements around your policy definitions themselves. So I recommend you check that out for just some best practices and recommendations from the Styra team on how to structure OPA.
Gotcha. Because looking at it, it seems like the organization, the way that you structure the policies is kind of however you want to. It's just when you decide to turn one on, that's when you decide that it's applied to something.
Yeah, and I guess in the way that's similar to Terraform in that you can structure your configuration however you want, but Terraform will evaluate everything that's there together within that system at runtime.
True. Thank you.
Yeah. So my run has finished. The task has passed as expected. And if I jump into the details, I should see a successful decision. And I do. So I know now that any of the resources that I'm trying to create within this run satisfy all of the policies that I have defined within this TFC system. So if I go back to the terminal, I can create my resource. And this allows my engineer to create that security group to troubleshoot the incident. So you now see a difference, the two different types of policies that you can use OPA for. As I showed, there's infrastructure configuration enforcement. So I can use either my own policies to validate, infrastructure configuration based on those plan details, or some of those publicly available policies that are maintained by Styra. For certain types of systems, I believe it might be limited to Kubernetes right now. You can actually also use compliance tax if you're a paid Styra user systems to make sure that your infrastructure is configured to industry best practices. And you can also use those plan details for other checks on your organizational practices. So the example that I showed you earlier is just around no Friday or no Tuesday deployments unless you're a certain user. But you can use the plan details in some other ways. So you can parse the plan output to make sure that all of the provider versions are of some minimal level. You might want to pull in details from a PagerDuty integration and check whether there are any active incidents, prevent any deployments at that time to avoid introducing any additional instability into your environment during that incident. You may also be able to pull in data from your calendar, and if there's a company board meeting, you can block deployments at that time to stop any system instability during important events. So there's really a lot of variety available for the types of policies that you can define using OPA and this run task integration. But that's the end of my resource creation for now. Cole, are there any other questions from the audience?
Actually, you just answered the final one, which was just going to be, what other cases can you use policies for? So nice. You pretty much nailed it there.
Yeah, so, and I'm sure you can research a ton more options online for other data sources that you can pull into your policy definitions. Look through that plan output, see what other fields are available for you to do those checks on, and that'll give you some more peace of mind that your infrastructure is configured to your organization standards. But in the meanwhile, that's the end of the infrastructure provisioning. So I'm going to clean up the resources to avoid leaving everything running. Run a Terraform destroy. And nice. Jump back.
So just for question for you, just almost sort of a clarification around the concept of Styra OPA. You're adding a new web app to what it is that you're doing, but in essence, we are sending up some information about our plan. What is it we intend to work on? Styra is taking that, it's going to check it against pre-made policies, ones that we write, and then send that back to Terraform Cloud, sort of in a nutshell, how Styra works with TFC, yeah?
Yeah, that's right. So it'll run between the plan and apply stages within your provisioning workflow and send those plan details. And you can configure the external tool with whatever checks are appropriate based on that response code and the enforcement level that you set within the Terraform Cloud Run Task. Your run can either continue or it'll stop if there's a failure in the case of that mandatory enforcement level.
Nice.
So to recap, in the workshop, I showed you how to use a precondition for configuration level validation. This specifically was using the precondition to check that that Bastion instance was not over-provisioned with more cores than necessary for its function. I then configured and used the Styra run task to enforce OPA policies within my Terraform Cloud workspace. And I also showed you how to use OPA to enforce both infrastructure and organization standards within the workspace that I associated it with. So those validation mechanisms are for the provisioning of your work, of your resources within your organization. This morning, you may have heard, we also announced a new public beta available for Terraform Cloud for business users for drift detection. So this extends validation to your infrastructure lifecycle beyond that provisioning time. Drift detection, if enabled for your workspace, will run checks against the resources that are managed within that workspace and check whether the real-time configuration of the deployed resource itself matches what's tracked in state. So I think it performs the checks once a day right now. It'll send you notifications if there's been any drift within that workspace. So this extends the validation beyond just when you create the resource. You've deployed it. Now with drift detection enabled, you can have peace of mind that if anyone has modified the resources outside of the infrastructure workflow, you'll be aware of it and you can make that decision to remediate it. I know that in my past life, maybe I went and modified a security group, just as we did here, to debug a production incident. And perhaps the run task would have blocked me entirely. Go through the console and update it. Drift detection will actually let you know that someone has modified the resource outside of your Terraform workflow. And that ensures adherence to your infrastructure as code practices rather than ad hoc manipulation of your resources. So you can follow along with this tutorial and try it out yourself by visiting learn.hashicorp.com, and the tutorial should be listed in the chat window as well. And if you have any questions for us, please reach out to Team Terraform Education at hashicorp.com, and we'll be happy to get back to you. Cole, before we wrap up, any final questions sneak in there?
I do not believe so. It looks like we're clear. You explained it so clearly.
Nice, thank you. Cool, so I think we can wrap it up there.
If there are any other questions for anyone watching, please feel to reach out, put them in the chat. We have all sorts of people standing by to answer them. And if you're there, you can just pull any HashiCorp employee off, and I'm sure they'll have answers for you as well.